Stem cell research is one of today's most promising medical endeavors. To date, we have found cures for multiple conditions using stem cell therapies. Blood disorders and cancers, autoimmune and inflammatory diseases, orthopedic and musculoskeletal conditions, neurological disorders, cardiovascular diseases, metabolic and endocrine disorders, as well as skin wounds and inherited immune system disorders, have all found great success using stem cell applications to heal. Despite the vast potential to improve human life, there are arguments against using stem cells. There are some reactionary issues with patients, some ethical issues with growing cells in lab conditions, but the greatest arguments against such treatments claim a moral superiority on the subject. In the grown stem cells, the standard practice is to take adult stem cells and genetically reprogramming them into an embryonic state. The quote-unquote moral issues of using embryonic stem cells come from misconceptions surrounding the acquisition of the stem cells. Most people believe that abortive procedures are the source. This is a falsehood. In vitro fertilizations that are not used to impregnate get donated. The vast majority of embryonic stem cells are from post-birth donations of placentas and umbilical cords. The invasive nature of some adult stem cell acquisitions is another issue. Bone marrow, liposuctions and tissue biopsies require surgical procedures to obtain viable stem cells. In lab tests, embryonic stem cells reproduce through a test cycle in 28 minutes. In adult stem cells taken from invasive sourcing, the cycle takes 4 to 6 days. There is one source of viable stem cell acquisition that is non-invasive that gets highly overlooked though. A woman's menstrual cycle is a viable source of stem cells. Women have an average of 400 cycles in their life. The uterine wall provides a reliable, renewable stem cell production with every period a woman has. Stem cells collected from menstruation. Blood has the same reproduction rate, but a slightly longer cycle rate in lab experiments. The 4 to 6 day cycle rate of other adult stem cells is faster than the 10 to 14 days of menstrual blood stem cells. The slower rates of menstrual stem cells make them suitable for lab testing in disease modelling, drug screening, and immunomodulatory studies. It is safe to say that the non-invasive collection, high-yield reproduction and potency of menstrual stem cells is comparable to or superior to other adult-sourced stem cells. It is no coincidence that the cures that may be found from using menstruation stem cells could bring life-changing potential, since all human life comes from between a woman's legs anyhow.